Today we're looking at inverse trig functions, but most of what we're doing today is kind of review from pre-calc. We'll get into the derivatives and antiderivatives the next few days. So first question here, does y equals sine of x have an inverse function? Yes or no? No? Yes? No? Yes? No? You're both right. Yes and no. Huh? Well, I heard it out there, the horizontal line test. It doesn't pass the horizontal line test, right? So that means its inverse is not a function because it wouldn't pass the vertical line test. So the whole function does not have an inverse function. Right, the whole function does not have an inverse function. But we've all used the inverse sine button on our calculator before, so we know it has to work somehow. How does it work? How do we get around the fact that this whole graph does not have an inverse function? No, you're thinking of cosecant. Alright? The way we get around this is we just look at one part of the graph. If we look at sine from negative pi over 2 to pi over 2, this little part of the graph, that part of the graph passes that horizontal line test. Whoa. That passes the horizontal line test and has an inverse function. So we kind of just look at part of the graph for the inverse sine. So from negative pi over 2 to pi over 2, it does have an inverse function. And we'll define that inverse function here in a little bit. So we're just looking at part of it to kind of get around that. Cosine is similar. There's no inverse function of the whole thing, but if we look at part of it, we can make it work. Not the same part though, from negative pi over 2 to pi over 2, that doesn't have an inverse function, right? Because it goes from increasing to decreasing. Remember how we talked about monotone functions, how if it functions monotone, just increasing, just decreasing, then it has an inverse function. Well, this one increases and decreases, so it's not monotone for that part. For this cosine, we're looking at it from 0 to pi. So for cosine, we're looking at x from 0 to pi. And that's how we get our inverse function, just looking at that part and taking the inverse of that.